Claxton's Algebra 2, or actually Algebra 1 class. We did this in Algebra 2 earlier this year. I have a video posted, but it's not the one that I told you that I was going to post tonight. So if you look here, what I've done first is I've solved for y. That is the first thing that we want to do, is solve for y. So solve for y first. You can see the inverse operations that I use. Don't forget to flip it. Whenever you do divide by a negative, you have to flip the inequality, as I did there. So this is my work for equation 1 there. And I rewrite equation 1 right here. So we're going to go ahead and graph equation 1 first in green. I'm going to OLS first, outline, label, and scale, to make sure I pick up those easy points, as that is the x-axis, and I have the y-axis up here. I'm going to go up 3. Remember how I said I was going to scale? I'm just going to scale as I go. I just used 3. I'm going to go ahead and plot the point 0, 3, since that is a y-intercept. I know that's a y-intercept. I can follow my slope from there. I could go up 7, up 1, 2, 3, 4, 5, 6, and 7. And up 7 from 3, I know that's going to be 10. And I know I'm going to go right 6. So 1, 2, 3, 4, 5, and 6. So up 7, 1, 2, 3, 4, 5, 6, 7. Right 6, 1, 2, 3, 4, 5, 6. Make another point. In the same respect, if I wanted to be sure about it, I could go down 7, 1, 2, 3. And then I'm just going to go down 4, because I know 4 plus 3 is 7. So that's negative 4. And I know I'm going to go left 6. So I don't really need to count that out. I'm not going to bore you with that. So my other point on this line would be right here. And I'm going to go ahead and graph that line now. So let's graph that line. Does that line need to be dashed? Okay, or does it need to be solid? Well, that line needs to be dashed. So I'm going to go ahead and draw that line. I'm going to try to draw that line here in green. I'm going to go ahead and choose the dashed option there. So let's go ahead and draw that line. I'd like it to be just a little thicker, but hopefully you can see that's dashed. And remember, I go ahead and extend that line to make sure that that my next line, I'm going to extend it the entire length of the graph. Okay, next up, we're going to graph equation 2 down here. That's y is greater than or equal to. Oh, you might be saying, Mr. Claxton, wait a second, you forgot to shade. This is a linear inequality. You forgot to shade that. And of course I did. So we're going to go back. Y is less than. Because y is less than, that means I shade below the line. So which way is below the line? Well, you got it. It would be down. I like to go ahead and make my marks somewhat perpendicular to the line. You'll see why later. So we're going to go ahead. This is almost, dare I say, fun. I shade below that line. Oh, goodness, I got outside the lines. Alright, so sorry to waste your time there. Didn't learn how to color well whenever I was in elementary school. So now it's time to graph equation 2. So we're going to go ahead and graph equation 2 now. Y equals 2x minus 4. I got that by dividing by 4 on each side here. Do not need to flip the sign, since I did not divide by a negative. I do not have to flip it. So I know that one of the points on the line is going to be at 0, negative 4. 0, negative 4. Oh, let's switch colors, Mr. Claxton. Switch colors. Alright. 0, negative 4 is called the y-intercept. So I know my y-intercept, just like I graphed it in green, is the point 0, negative 4. So 0, negative 4. Go down 4. Oh, look at that. 0, negative 4. Well, let's go ahead and graph another point on the line. I could follow the slope. I could go up to right 1. I'm not really satisfied with up. Well, Mr. Claxton, you just went left. Whew. Been a long day, folks. Been a long day. So up to right 1. Up to right 1. Up to right 1. Okay. Still not quite satisfied, so I'm going to go up to right 1 again. I've got a whole series of points there. I know I'm getting really, really close to that other one. Up to right 1. Oh, getting so close. Up to right 1. I'm going to go ahead and draw the line now. I know that this line needs to be solid because it says greater than or equal to. That little line down there means that I got to make a solid line. So I'm going to go ahead and make that solid line. I would like that to be in black. We're going to try and extend it out here so you can see that point of intersection. And that's going to be a black line, if I can select it, that is. Select that. Kind of being goofy here. Make it black. There we go. Okay, let's see here if I can now... Okay, let's go ahead and click off the selection, on the selection. I'm going to see if I can extend this line now. Okay, so you can kind of see where they would intersect. Okay, they're going to intersect right here. I need to shade above this black line, right? Above that black line. So I know that I would shade this way. And it's that intersection that's important there. Okay, again, this just keeps going forever. There are an infinite number of points in this shaded area. I bubble that in, making sure to color in the lines. And if I would have extended my point down here, you would see that that area just continues to grow without bound. Okay, so this is the area where I can throw any test point in here and it will give me a true statement for the system of linear inequalities. I hope this has been somewhat helpful for you if you don't know how to graph linear inequalities. If so, then please let me know.